Hi, I'm just going to do another run through with the home-built Wah circuit I made a couple of years ago. I had a couple of questions about it. On the video you can't see the value of the components, so I'm going to have a close view walk through. The transistors in use are MPSA 13. EBC connections, the flat face is facing you. There you go, so my camera will keep in and out of focus. And PSA 18, they're facing at you, flat face, EBC. You can pause this video at any time and look at these values. This seems to be the little power supply stabilizer. Main capacitor seems to be 0.1 microfarad, and this is, looks like what's that say? ZL9M3, some kind of Zener that's going to hold the voltage at 9. If you're running on a battery, you might want to lower that value because it's a 9-volt battery will drain off, but if you're running on a power pack, then yeah, this will stabilize your power supply for you. Okay, let's have a look at the input. There's a question asked one of my subscribers about this input here. You'll be plugging your jack socket in there from your guitar, and as that ball end of the jack goes in, what it's actually doing is lifting this contact up. That's what this arrow represents. And the question was, what does this X mean? I couldn't remember either, so I've had a look over. And if you go through all the circuitry, this is where you'd be plugging in a lead, say we're going straight to the amplifier. It's wah pedals just from the guitar in line to the amplifier. And again, same thing happens, you plug your jack in, don't you? And the ball end goes in, you hear the click. It's actually pushing that contact up. And we have another X here, so these must be connected through. Okay. And if you're just doing that, then you're shorting out the input to the output, basically. So I'm wondering, in other examples of amplifier circuits and guitar effects pedals, usually this contact here go down to earth. Just earth off the input, ground it off, and there's no signal coming in. It kills the circuit because it's grounded off. It can't get a signal. The only signal it can get is when this contact's raised up. When you plug in and this little V sits in that ball end of the jack, and the long stalk bit sits here and it grounds out, grounded the cable. And the positive tip of the plug sits here, raises this up, disconnects that, takes it off the earth, and becomes hot, becomes live. The signal's coming in now. You play guitar and your pickups are picking up the signal you're playing, and it's bouncing off this capacitor like that. It's all energized now because this is not grounded and this is open, live, waiting for a signal, and that's off your pickups. The transistors are charged all the way through, ready, first stage amplifier. So the question was, what's this resistor? Couldn't read the value. It's 2.2 megohms, badly written. 2.2 megohms. What's this one, he says? Is that a picofarad or a microfarad? Looks like a picofarad. A small one. This was probably for noise. Passing high and low frequencies. You're getting rid of some of the noise coming in. Some kind of, high-low pass filter. A self-regulating transistor amplifier. put your signal through. So it's all biased up. And there goes your signal. Okay. We've got some notes here as to what things are doing. So we've gone from the first stage, and we're going to go through again into the next stage and towards the magic, the wah system. Here we have some values, 68K, this is like the MPSA 13 by the way, 10K, 1.8 meg, 1K, 9 volts, 22 picofarads, we've done those. Okay. This one here affects the signal level output. It says 33 to 47K, lower input impedance near the input buffer, 56Ks, must have been the value I've selected. Here's an input capacitor, it's a 103, 0.01. So if you put a larger capacitor in, bigger for more lows, stroke fatness. Okay, then the opposite will happen. The smaller the amount. So now, yeah, so we've passed through the stage, we've done a bit of selection on what sound shaping initially is going into the system. Is it a nice big fat sound, or is it skinny? However you want to tailor it. Okay, and how much signal level comes through after the primary, the first preamp stage. So here we go, and again we've got a second amplifier. After we've done a bit of filtering, second stage amplifier. But also we've got this value here, resistor to 1.5 kilo ohm. This is part of the feedback loop, essential. Okay, you need that feedback loop in a system like this, and many other amplifiers, that's about every amplifier requires a feedback system to be effective. So we're coming to this second stage amplifier with feedback, 9 volt rail again, 22 kilo, MPSA 18, 470 ohm, I presume. Can be reduced down to 200, 390 ohms. So that'd be a 470 ohm. Okay, so the second stage amplification is happening now. And we're now into the magic. Your signal is passing through to this final stage, something like that, to get back out to here. Oh, this is part of the feedback system, I think. Those aren't connected because it hasn't got a dot. There's dots, it's connected, and no dots, those aren't connected. Okay, so your signal's going out through there. Okay, bouncing this. And there's your wah pot. You're operating with your foot. There's got another note on there, isn't it? This was an idea for if you wanted to use what do you call them? Light dependent resistor type wah pedal instead of the pot type. Okay, that's 100K. That's what you're operating with your foot. 470K resistor, done that one. 33K resistor in line with this 500 millihenry coil. This affects the Q factor. Maximum 100K. 51K is good. There's another range here. I've written 40 to 47K. And this will be I'm pretty sure it's affecting your scoop of range of frequencies you're scooping through. Because when you operate the wah pedal, you see you're got low frequencies, just like a graphic equalizer. Imagine it exactly like that, as many sliders as you can imagine, going from the lowest frequencies to the highest you can possibly hear. And basically, what the circuit is doing is reducing the level of the frequencies at this side and coming up like a bell shape, and only accentuating this band of frequencies. But as you operate your foot pedal, what you're actually doing is moving this bell shape up and down the frequency range, and usually within a given frequency bandwidth. So say when you pull back on the pedal, this bell shape shifts down towards the lower frequencies and makes lower frequencies sound more. As you push forward, this scoop moves up into the higher frequencies, and you hear that higher sound of the wah pedal, the more clicky, percussive sound. And then you learn how to flick this backwards and forwards across the sound frequency range and shape your playing with it, and it becomes very expressive. Such is the art of playing wah pedal, of which there's many examples you can see from many great players. So yeah, these coils, you can buy them online, £20, dollars, whatever currency you're working in your shop. You know, you can, more you pay apparently for quality, but you pay as much as you want. I used a coil out of an electrical contactor for a laugh, and it worked. I tried little transformers and other things. They worked, but you know, if you want the real McCoy, use a proper custom built wah coil that you can buy online. And this circuit is, I got this online. It's a copy of a Cry Baby Wah circuit, and I read up on what all these different components do and what happens when you change them, so you can customize the pedal to how you like it. What's this one say now? 4.7 microfarad. Can be lower, but not too much. Doesn't say what it does though. Center frequency. Increase the value of this, you get more bass. Make it smaller in value, more treble. So we talk about center frequency. This is where we go back to our diagram. Center frequency. So this capacitor here is kind of setting where this bell shape will be. So let's say, for example, the current value we've got, 103, which is a 0.01 microfarad. Let's say using that value capacitor will give you this frequency range the most accentuation. And as it gave in the example there, if we make that a bigger value, so let's say we put a 104 in, massive jump in size, and this becomes 0.1. But this bell shape will actually be shoved back down here. And when you operate the pedal, it will come even further back down into the bass zone, lower frequencies, and not come up any much further than the midpoint. And in opposite, you make that even smaller. So if we put a 102 in, then this bell shape will start up here. So you'll get more trebly sound when you switch the thing on and pull back on the pedal. And when you come back to here and go full forward, it'll be right up here, really scratchy and tinny. So it's essential to find a balance there, the kind of capacitor that suits you. And of course, remember, I mean, there's a single capacitor. If you put capacitors in parallel, it doubles the value of the capacitance there. if you put them in series, so if you added another one there, you're going to half the capacitance. It's the opposite to resistance. I don't know if you know resistance and resistors and how they work. If you have a resistor, I can't give you there's not a good enough example here. If you had one resistor, say a value of 10, and then you add another one on, you get 20 ohms resistance. But if I had a 10 here, I put another 10 underneath, coupled each end together, and you've halved the value. Okay, parallel resistance that will half the value of the resistance. You'll end up with a 5 ohm total resistance, but it's opposite with capacitance. So put one in parallel and you can increase this value. So if you didn't like that sound, you could literally get a capacitor in your hand and put it across the one on the circuit board and tack it on, and it'll instantly change the sound for you. If you don't like it, you can just take it off. Anyways, yeah, so that's a vital part of the sound, as is this and this. These are the things that shape. You can really customize the pedal by tweaking these. We've got an electrolytic capacitor here. It's a 4.7, as I said before, 82k resistor down to earth. Pot was described before, a 470k, another one there. That's a U, 224.22 microfarad. Be a ceramic or something, or you get high quality capacitors rather than using the ceramic disc ones because the tolerances are too wide. You need high tolerance capacitors for this if to really get a good sound. It looks like a 224 capacitor, which is 0.22. I'm going to have the MPSA 18 on the output, 1k in, and a 10k in this feedback. Going back to remember we were saying about the second stage amplifier with feedback. So once you've, you're playing away and you've been playing around with your foot pedal, this thing here is sending part of the signal back through here, bouncing this little capacitor. So you want a really good quality capacitor here, because that's transferring your signal through and out to the amplifier. So your good quality capacitors throughout the whole thing. No cheap stuff. If you really want to build one of these things, go for good quality stuff. Yeah. Well, there you go. If you've got any more questions, I'll be glad to answer them. I'm sorry the camera keeps going a bit blurred now and again. There we go. Thanks for watching.